Good morning, students. Welcome to the class of Technomathematics. Today we have taken three questions from the circular areas. Okay. In the first question, a motorcycle is given whose wheel is shown like this. Okay, the wheel of a motorcycle is of radius 35 centimeter. So the radius of this wheel is nothing but 35. So let us say r equal to 35 centimeter. Right. Now just we need to consider that what are the units given that need to be taken proper care of. So this is in centimeter. Now it has been asked that how many revolutions per minute must the wheel make. Okay. So the question is that this will make how many revolutions per minute, right? So that the wheel make so as to keep a speed of 66 kilometer per hour. For this need to be calculated for 66 kilometer per hour, right? This is the question which is given to us. Now let us solve it. Into this question we need to understand that definitely the radius of the circle is in centimeter and the speed is in kilometer per hour. So what we can do, when the motorcycle will run, then definitely the circumference of the wheel will be covered out, right? So this distance 66 kilometer per hour, let us say in n revolutions, it's centimeter, right? So let us say in n revolutions per minute, the let us say n revolutions per minute, the speed is achieved as 66 kilometer per hour. This is achieved, right? Then we can say that n revolutions, that means n times this 2 pi r will be covered, right? So first of all we need to convert this 66 kilometer per hour centimeter centimeter and minutes, right? So 66 kilometer per hour, the kilometer is in numerator, so we can convert into centimeter, that in 1 kilometer 1000 meters and in 1 meter 100 centimeters, right? So this much of centimeter will be there when the speed is 66 kilometer per hour. Then this much of centimeter, instead of hour we need to take care that this should be in minutes, right? So this hour should be converted into minute. To convert that hour into minute, we know that 1 hour consists of 60 minutes, right? So this will be in minutes. So basically 66 kilometer per hour will be equal to 66 into 10 power 5 divided by 60 centimeter per minute, right? So this can be further simplified, and you can see this 0 and this 0 is cancelled out, and here 6 will divide this 66 in 11 times. So this will give you 1 4 times 0, 1,10,000 centimeter per minute. This is the required speed, centimeter per minute. So we converted this kilometer per hour of speed, 66 kilometer per hour can be written as 1,10,000 centimeter per minute, right? And here the revolutions per minute need to be required. So we have, as we have assumed, in n revolutions per minute, let us say this speed is achieved, right? So we know that in one revolution the circumference of the wheel will be covered, right? So what we will do, we will just simply write n revolutions, that is n into, this revolution is nothing but 2 pi r, 2 pi r, right? If this is made per minute, this is what, this is nothing but in one revolutions we cover 2 pi r distance, right? And that is equal to, when this will be covered, then we achieved this speed of 110,000 centimeter per minute, right? So we just calculate this value of n. So the value of n can be calculated as equal to 110,000 divided by this 2 pi r, that is 2 into 22 by 7 into r. It's given that the radius of the wheel of the motorcycle is 35. This is the wheel of the motorcycle, that is radius is 35. So just write 35 over here. Now do your calculations. 7 will divide 35 into 5 times. 11 will divide 22 in 2 times, right? So this will be coming as 1 4 times 0 divided by this 4 into 5, 20. This is the value of n. This will give you, on further calculation, 1 0 and 1 0 will be cancelled out, and 1000 by 2. This will give you the value as n equal to 2 will divide 1000 in 500 times. So this will give you the value of n as equal to 500. So we can say that this is our answer. So the motorcycle tire need to be revolved motorcycle tire revolution per minute should be 500, right? This will lead to an speed of 66 km per hour, right? So thank you so much for watching, students. Now let us take the second question of the today's series of live area of circles. Into the second question, question number 2. What is that? Let us see. In the question number 2, we have taken a circular park is surrounded by a road 21 meter wide. A circular park is given to you. Let us say this is the circular park which is given to you, right? Into this circular park, this is a circular park. A circular park is surrounded by a road 21 meter wide. So this is surrounded by one road, and that road is nothing but 21 meter wide. So the width of the road around the park is 21 meter. This is 21 meter, and such road is just constructed outside this circular park, and that road is spreaded uniformly across the walk so that you can walk across it. Okay, and the radius of the circular park is also given to you. First of all, let us draw that the width of this road is 21 meter across, right? Now if the radius of the park is 105 meter, right, the radius of the park is given to you as 105 meter. That means this radius is given to you r equal to 105 meter. So first of all, match the units, meter and meter, both are same, right? We need to find the area of the road. So from here, if we consider the green circle, the bigger circle, let us say the radius of the bigger circle here till here is capital R, right? Then we can say that R is nothing but a small r plus 21 meter, isn't it? Because this circular park is surrounded by 21 meter wide path. So the bigger circle, this one, the bigger circle, this bigger circle will be having a diameter of capital R, and that is equal to a small r plus 21. We need to find the area of the road. So road area can be calculated by taking the area of the bigger circle minus area of the smaller circle, right? What is the area of bigger circle? That is pi to capital R whole square, because area of circle is pi r square. Pi into capital R whole square minus, this will be subtracted with area of the circular park. The area of the circular park will be pi into a small r square, right? Now we know the value of take pi as common, we know the value of capital R. So capital R is R plus 21. So we can say that this is nothing but 105 plus 21, that is equal to 126, right? So capital R is 126. So let us write 126 whole square minus small r, that is small r is 105. So let us write 105 whole square. So this will be the road area which is surrounded across the circular park. So this we are calculating. This is the road area. Right? Now, what is the value of pi? Is 22 by 7. Just apply a square minus b square. This will a plus b, that is 126 plus 105, that is 231. So when you add it and when you subtract it, 26 minus 5 will be 21, right? Now just solve it. This much of meter square is your area of the circular path surrounding this circular park. This is the area of circular path which is surrounding this circular park. So 7 will divide 21 in 3 times. So this will give you 231 into 22 into 3. So when you solve it, 231 into 22, this will be 264. 264. So this will give you 285082 multiplied with 3 meter square. This is the area, right? This is the area of the circular path surrounding this circular park, right? Now when you just multiply 5082 with 3, you will get 6, 24 carry 2, 15. So 15,246. 15,246 meter square is the area of the circular path surrounding this circular park, right? So this area is nothing but 15246. 15246. This much of meter square. Now students, quickly coming to the third question of the today's live session. The third question is that a square is inserted inside a circle, right? Hi Matthew, Salmida, Centos. So into the third question of the today's series, a square is given to you which is inserted inside a circle. So let us say this is a circle, okay, and inside this circle a square is given to you. So let us say this is the square which is inserted inside this circle, right? So a square of diagonal 8 centimeter is inscribed in a circle. So diagonal of the square is 8 centimeter. You know the property of a square, that the diagonals of a square are bisecting each other at equal centimeter, at equal distance. So we can say that if diagonal of a square is 8 centimeter, right? If this is 8, then we know the property of a square, diagonals bisect each other. Then we can say that this portion will be the radius of the circle. So we can say that radius of circle, let us say OA, is equal to 8 by 2, because this complete length is 8 centimeter. If this is 8, and then OA will be 8 by 2, which is equal to 4 centimeter. Now, what is the area of the? It has been asked that find the area of the region lying inside the circle and outside the square. Area inside the circle and outside of a square is what? That need to be calculated. Area inside circle, outside a square. So definitely this will be the area of the circle minus area of the square, right? This will be the area of the circle minus area of the square. So what is the area of circle? This is area of circle minus area of a square, right? So what is area of circle? Area of circle is pi r square. So that is pi into r. We calculated OA, the radius, as equal to 8 by 2, which is equal to 4 centimeter, right? So it will be 4 square. Now what is the area of the square? Since this is 8 centimeter, then apply the Pythagoras. We know the sides of a square are at 90 degree. So if the length of the side of a square is x, then all sides are equal. Applying Pythagoras across this right angle triangle, what we will get? From here you can see x square plus x square will be equal to 8 square. Here x square plus x square, this is x, and this is nothing but 8, right? The diagonal is 8, which is acting as a hypotenuse, and the sides are x. So this will show you 2x square equal to 64, and x square is nothing but 32. So just keep this data with you. This much of x square is 32, which is nothing but area of a square, and area of a square is side square, which is equal to 32. So just insert this 32 over here and subtract it from the area of the circle. This will give you this area, the area outside a square inside circle. This has been asked, this area, right? So this is given by pi into 4 square minus 32. This is area inside circle, outside a square. Now from here we can take pi as common, that is 3.14 multiplied by 16, because 4 square can be taken as common from both of these, and this will give you 1 minus pi cannot be taken as common because 32 only will be subtracted. So pi into 16 minus 32, simple. So from here you can simply take 16 as common, and when 16 is taken as common, when 16 is taken as common, we have 3.14 minus 2, because 16 into 2 will be 32. So this will give you 16 multiplied by, when 3.14 subtracts 22, it will be giving you 1.14. Now simply multiply it. 16 into 1.14. So 114 multiply with 16, 6 for 24, 8, then 411. This will give you 4. This will give you 1824. This will give you 1824. Now we arrive to our answer. This is equal to 1824 centimeter square, and just decimal over here. 18.24 centimeter square is the area inside circle and outside a square. Area inside circle, outside a square. So this is the area which we are talking about. Okay, and this is equal to 18.4 centimeter per square. So with this, students, we can close today's session, and these 3 questions of area of circle and related concept have been discussed. And for any query, you can just put up into the comment box. I will get back to you. Okay, so thank you so much for watching. Be connected. Take care. Happy learning. Bye bye. See you.